So this week we're going to work with word problems on trig. Nothing has changed. The rules are still the same. We're going to identify our angle, label the triangle, pick the function we need, and solve. Okay, so those same 4 steps. We've just maybe added a little bit more on the front end that you have to actually read the problem. So here is our SOHCAHTOA. In case we have forgotten what we're doing here. And let's just jump in with this first problem. An airplane takes off at an angle of 5 degrees from the ground. They have labeled that angle for you. So I'm going to stop right here and label my triangle. So this is the side opposite, this is the hypotenuse, and this is the side adjacent. Back to my problem. If the airplane traveled 100 miles, how far is it above the ground? Well, I said that a little backwards, but anyway. Round to the nearest foot. Note that there are 5,280 feet in 1 mile. Why did they tell me that?
So you can convert feet.
Good. We have to convert. We have to multiply to get the feet. Okay? My guess is that a couple of you would have just taken these numbers, solved it, and left it there. You just did that. Yep. So let's actually solve the problem. We are looking for the height of the airplane, and we have the hypotenuse. So which trig function are we using? Sine. And we have our 5-degree angle.
Is it sin or sine?
It's pronounced sine. The actual word is that. And we abbreviate it because writing that extra E at the end is just apparently too much for everybody. So we abbreviate it sine.
So it's
Sin.
sine, tangent, and
Cosine.
cosine.
Because they are partners in crime. Sine and cosine. Okay? All right. What's our step here? Do you remember how to do this? It's been a while. What do you know, Haley?
Multiply by 100.
Good.
Both sides.
Multiply both sides
And I
again.
get 100 sine 5.
Well said. So we go right to our handy dandy calculators.
And I got 9.
And you got
47. 1.
you got something. Come on.
7. Have it on there. I have it on there.
I went right to feet on mine, so I have to.
I need to go right inside.
Please keep all of that number on your calculator. And what do we have to multiply by to convert to feet? 5,280. Okay, so let's go ahead and do that. Okay. Now you may round to the nearest foot. Okay? It is a big number. So our height for this airplane is 46,018 feet. Please don't round until the very last step when you do a problem.
Okay, if you use X instead of
Sure.
B.
Moving on to number 2. Our airplane has taken us all the way to Paris. And Pierre is walking his dog. He sees the Eiffel Tower and somehow he whips out his handy dandy protractor that he carries with him and realizes that the angle of elevation means to go up. So this angle down here is 24 degrees.
Very unrealistic.
If Pierre is 2,215 feet from the base of the Eiffel Tower, so that's his ground distance, if you will, how tall is the Eiffel Tower? So this time I read the problem and I labeled my picture with the information. Now let's jump into our process. We're going to label our triangle. And then we need to pick. We need to use opposite and adjacent. So which trig function, tangent is the trig function we will use. And what is my ratio over here? What's my fraction gonna look like? I agree. Okay. They gave us the information in feet and we're supposed to round to the nearest foot, so we don't have to do that whole converting thing. This time when you get your x value, done, good to go. Okay? Because they gave us all of our information in feet and asked us to talk about feet. So on our handy dandy calculators, we're going to get a beautiful number. 96?
Yeah.
I agree. How are we doing so far? 2-word problems down? Everybody's still breathing. Fantastic. 2 to the back. Harold is hang gliding off a cliff that is 120 feet high. I hope Harold has his safety gear. He needs to travel 350 feet horizontally. So 350 feet across, which they've identified down here at the bottom. 350 feet across to his destination. To the nearest degree. Stop right there. We're finding an angle. What are you thinking we have to do for our trig function? Yes, the inverse trig function, because we're looking for an angle. Okay, what is his angle of descent? This one right here. That angle's not inside the triangle. Oh, I could do this, you're saying? Oh.
It's a giant rectangle.
All right. And 350 feet. So I think Victoria said rectangle. Yeah?
Yeah.
Real quick, can I connect back to something I believe you learned in 8th grade? Alternate interior angles. Well, that's 3 words. Alternate interior angles are angles made by 2 parallel lines. So our 350 measure cut by a transversal, the diagonal. Angle A and this angle down here will be congruent. Alternate interior angles. Does that sound like maybe something you heard in a previous math life?
Yeah.
Okay. Moving on then before, let's just move on. Okay, so I gotta label a triangle here. This is my angle, so this is the side opposite. This is my hypotenuse, and this is my adjacent. Excuse me, what trig function are we using? Opposite and adjacent would be tangent. Very nice. What's my fraction? Nice. Opposite over adjacent. And I believe it was Miranda told us that we had to use not that, but this, and in our handy dandy calculators, we are typing in a fraction this time. Well, that doesn't look like a 3, does it? That's cute. Like, cute little baby one. What are we rounding our angle to? Do we know? Nearest degrees, so angle A measures 19 degrees. Wonderful.
So then angle, whatever that one is.
Correct. This one is also 19 degrees. This would be the angle of elevation as you're looking up. Elevation. Boy, it's a good thing I don't teach you. And this is an angle of depression because you're looking down. Oh no, the pictures are gone.
I do.
Well, we're gonna have to get out our creative. Yes. You are welcome to draw a picture. Remember, you don't get credit for how artsy your picture is. So don't spend a lot of time making a beautiful ladder and building for this one, for
You can't
example.
get away with just drawing pictures and distract people.
No. Number 4, Francisco is trying to reach a window with a ladder that is 15 feet long. Is the window 15 feet long or is the ladder 15 feet long? The ladder, good. Find the angle, whoa, find the angle. Inverse again, very nice. That the ladder must form with the ground in order to reach a window that is 11 feet high. Sketch a diagram below that represents the scenario. So here's my picture of the ladder leaning against the window. How'd I do? Good. Good, good. So what do we know? The window is 11 feet high. And this is my ladder leaning. Good. What do we have to find? Which one?
That the ladder forms with the ground.
Forms with the ground. So that would be this angle down here. I'll put an X. Questions so far?
No.
Carrying on then. All right, this is hypotenuse, this is opposite, and this is adjacent. So we're using opposite and hypotenuse. Oh, we're going to use sine, very nice. And we already talked that it was going to be the inverse function. And we are rounding to the nearest degree. 41?
47.
7, good. How do we do? We made it through our first one without a picture. Are we okay?
Well, technically, you did have a picture.
We had to make the picture,
Like, you still have a picture.
but we're all right. Number 5, we have a ladder that's 12 feet long. And it's-
favorite scenario.
Yeah. It's 5 feet from the edge of the building against which it is leaning.
Oh, that's a little bit close. I don't think it'll come up.
In order to be stable, the angle the ladder makes with the ground must be, oh boy, less than 60 degrees.
What?
Is this ladder stable? Always got to make it harder. Let's see if we can get a beautiful picture. Building, ladder. Beautiful picture. The ladder is 12 feet long. And it's 5 feet from the edge of the building. Does the 5 go at the bottom or on the side? On the bottom, good. Oh, that's a little difficult to see there. And it's leaning. In order to be stable, the angle the ladder makes with the ground must be less than 60 degrees. Do I put a 60 here?
No, it's gonna be less than.
Oh. I'll put X? Oh, so we're gonna do some comparing. All right. I'm gonna label. Now we can use cosine. Sooner or later you had to get it right. What did we get?
65.
Oh. So this ladder is not stable.
Even if it was, I still wouldn't climb it.
You're right, you probably would look at it and say,
No.
not me. Very nice, very nice.
We got
Bless you.
trees.
Oh, we shifted to trees, very exciting.
It's always shadows though, isn't it?
Yep, tree casts a shadow that's 32 feet long. Find the height of the tree, if the angle of elevation of the sun. Whoa,
What?
35.7.
That's not cool, man.
Round your answer to the nearest foot. All right, let's see how this is gonna go. Tree, shadow, beautiful picture.
I thought we had to draw a tree.
You can
This is a tree.
I do.
use your imagination and
It's
see the tree.
Why?
The shadow is 32 feet long. Shadow goes where? On the bottom. Good. The height of the tree. Find the height of the tree. Find the height of the tree.
X's.
Thank you. If the angle of elevation, where does the angle of elevation go?
On the top. Or on the
No,
bottom.
no, no.
One of those answers is correct. Which way does it go?
On the bottom.
On the bottom. This is our angle of
How do
elevation.
you have 37 from 35.7?
Oh, we can have all kinds of degree measures. We can measure degrees in not just whole degrees, but minutes and seconds. Have you ever seen like longitude or latitude readings? Those are degrees, minutes, and seconds.
Oh, wow.
Let's not panic about the 35.7. Let's pretend that it's fine and see if we can figure out what's going on. So here's our angle. I'm labeling my sides, picking. Which trig function are we going to pick? Tangent. And my angle is this weird 35.7 thing. We're going to multiply both sides by 32. And our handy dandy calculator. Let's just type that in. Where's my calculator? 32 tan 35.7.
23 feet.
And correct, we're rounding to the nearest foot, so 23 feet.
Oh, wow.
Very nice. Whoops, not degrees.
These are probably the only word columns I have not hit this year.
Yeah, me too.